Matter, when subjected to enough energy and time, becomes sentient and ponders its own existence. What's the most amazing thing about the universe? That in the grand scheme of things we are all immortal. Our organic cells will die, our consciousness will cease, and we will no longer be able to directly observe existence, but the atoms that make up our bodies will simply be new compounds. And if energy is neither created nor destroyed, if our atoms continue to be, we will eventually make up the building blocks of new compounds. Pieces of us will watch the sun swallow up Mercury and Venus. Pieces of us will watch supernovae and black holes and all sorts of cosmic phenomena. Perhaps even one day our atoms will return to a nebula, and the cycle will begin again. A new star is formed, new planets begin to orbit it, liquid water forms on a small green rock orbiting this star, and an intelligent species evolves to travel to marvel at the wonders of our universe. One of my favorite shows is Battlestar Galactica, and one of the quotes that stuck out to me was, "All of this has happened before, and it will happen again." I tend to think there's some truth to that. I've had a couple friends and my grandfather die this year, and as an agnostic I am processing death a bit differently from the rest of my family. I don't think of death as the ending, as a finality. I don't think there is an afterlife as most religions conceive of it. I think that in a weird way, we all live forever. This is one I thought about recently. I believe that Carl Sagan said that we sentient entities are a way for the cosmos to know itself. With this in mind, when we think about the end of our universe, whether it be through a big shrink, big cooling, or what have you, we get apprehensive. We probably will never see this end, many of us will be dead. Yet, we still get a cold fear in our hearts. We are also a way for the cosmos to fear its demise. That every single random event since the dawn of creation, the birth and death of stars, planets, and galaxies, the very genesis of life, has led to you being here right now to ask this question. One of my favorite is about the number of unique orders for cards in a standard 52-card deck. I've seen a really good explanation of how big 52 actually is. Set a timer to count down 52 seconds, that's 8.0658 x 1067 seconds, stand on the equator. And take a step forward every billion years when you've circled the Earth once. Take a drop of water from the Pacific Ocean, and keep going when the Pacific Ocean is empty. Lay a sheet of paper down, refill the ocean, and carry on. When your stack of paper reaches the sun, take a look at the timer. The three leftmost digits won't have changed. 8.063 x 1067 seconds left to go. You have to repeat the whole process 1,000 times to get 1/3 of the way through that time. 5.385 x 1067 seconds left to go. So to kill that time, you try something else. Shuffle a deck of cards, deal yourself 5 cards every billion years each time. You get a royal flush, buy a lottery ticket each time the ticket wins the jackpot. Throw a grain of sand in the Grand Canyon when the Grand Canyon's full. Take 1 oz of rock off Mount Everest. Empty the canyon and carry on. When Everest has been leveled, check the timer. There's barely any change. 5.364 x 1067 seconds left. You'd have to repeat this process 256 times to have run out the timer. You can use similar math as above to figure that out too. We can use some pretty generous approximations. Wikipedia says that playing cards were first invented in Tang Dynasty, China, which has a start date of 618 AD. Let's assume two things, both absurd, that these playing cards are identical to the standard 52-card deck we have today. They weren't, and that in the 1,400 years since they were invented, the whole human population has done nothing but shuffle cards every second of every day. Further, let's assume that the current world population, 7 billion, has been a constant since 618 AD. So we have 7 billion people constantly shuffling cards. Let's assume they each shuffle a unique permutation once per second, as in OP example. So we have how many is that compared to the total number of permutations? A measly 383 asterisk 10-48%. I've been thinking for 10 minutes for how to put a number so small into perspective. So it's pretty safe to say that the chance that every shuffle has been unique since the dawn of the playing card is 100%, assuming, of course, that each shuffle is a good shuffle which truly randomizes the deck. Since cards generally come in packs, sorted by suit and number, this may alter the odds a bit, but probably not by too much. Imagine being transported to a parallel universe that was almost identical to our own. Somewhere out in the vastness of that universe, there is a tiny planet. This much is true in both universes. On this planet, there is a beach, and on that beach, there is a small stone. Once again, both universes are alike in this regard. Beneath that stone, however, there are several million grains of sand, and while they all in precisely the same location in each universe, one of them, a tiny speck of particularly clear quartz, hewn from a larger hole millions of years before, has a single atom that is positioned a fraction of a femtometer differently than its twin in the mirror dimension. You may think that such an insignificant difference would label these two universes as being functionally identical, and you would be right. In fact, they are so similar that the multiverse has long since combined them into one reality. That single atom in that tiny speck of sand on that lonesome beach on a distant planet merely occupies two spaces at once, seeming to an outside observer to vibrate back and forth at a predictable rate. That every atom in existence seems to do the same is probably a coincidence. The multiverse interpretation of quantum mechanics is an intriguing idea. There's a related thought experiment called quantum suicide. Basically, you try killing yourself with a gun that only fires when a spin-half particle, with two possible states, is measured to have spin in a certain direction when the trigger is pulled. In quantum mechanics, before the spin is measured, it exists as a superposition of both spin up and spin down simultaneously. If the particle is measured to have spin down, it doesn't fire. If it is spin up, it fires. But the idea is that to you, and you alone as the observer, it will always seem as if the gun doesn't fire. According to the multiverse interpretation, the particle actually collapses into both states upon measurement, but in two different universes. And usually we only see one because we as observers are randomly shunted into one of the possible universes along with the collapse of the particle's state. However, in this case, in one of the universes you would be dead due to the trigger setting off. So you should only experience the second possibility, i.e. staying alive, because that is the only one in which you are still conscious. No matter how many times you pull the trigger, the idea goes, the gun never fires, and you should always survive. From your own perspective, an outside observer, watching you carry out the quantum suicide, would not always see you survive though, since you would remain alive and conscious in both possible timelines, and to him you have a 50/50 chance of dying, as expected. How young is people look at the universe, being 13.7 billion years old, and say that is ancient. That is nothing. Stars will continue to form for another 100 trillion years. Even after that, stellar remnants will exist for quadrillions of years. Black holes will still produce energy that can be used by intelligent civilizations for 10,100 years. Keep in mind, if biological life doesn't destroy itself, we will just keep getting more and more knowledge.